Okay, now let's compare the two algorithms, Gaussian elimination and Cholesky algorithm, right? Now we consider solving linear system. Now, of course, we need to consider the special case, symmetric and positive definite. Of course, you can always use Gaussian elimination to solve the linear system, right? But now we have a special algorithm, Cholesky algorithm. Okay, let's compare. First step, we need to factor matrix A into L multiply L transpose, right? Now, we just use the two formulas. We can obtain the elements. It's okay for you? We just obtain the two formulas for general case, right? Okay, now, the computing order. From first column, L11, L21 to Ln1 to second column, L22, L32 to Ln2, and dots to last one. Okay? First column, second column, and so on. Right? Okay, let's count how many of multiplications and divisions we need. How many times? Okay? Now you see, here, we need a compute square. Each square need a multiplication once, right? And also we need here square root, right? So if we just consider the multiplications here, then we see k from 1 to j minus 1. So here we need j minus 1 multiplications, right? Here subtraction, right? Okay, here this step, okay, I write here j minus 1, right? And also here, you see, and here we have a multiplication, lik multiply ljk, and k from j minus 1. So again, we need the j minus 1 multiplication. And don't forget, we also need a division here, right? Division here. So we need the plus 1 division, okay? So actually here, because for L, this matrix, there are n minus j plus 1 entries in the jth column. It's okay for you? For jth column, how many elements here? It should be n minus j plus 1. It's okay because these are j minus 1 zeros. So n minus j minus 1 equal to n minus j plus 1. It's okay? N minus bracket j minus 1. Okay? Right? Okay. For each entry, now you see we need j here. This j, and also here we need the square root. So we count square root once. So also j, right? So that means for each element we need j multiplications or divisions. So okay, totally the number, the summation j from 1 to n, okay, for each entry we need j multiplications. We have n minus j plus 1 entries or elements, then product and summation. You will obtain this number, n cubic over 6 plus n squared over 2 plus n over 3. Okay, please check. You can check the summation by some calculation, right? Okay, now if you compare this cost with Gaussian elimination, can you remember what's the main cost of Gaussian elimination? Also cubic, n cubic. If you remember, it is n cubic over 3. Remember? Okay, you can check last section, right? Now you see the denominator. Here is 6, but here is 3. That means the cost is half. Almost, of course almost, because we have other terms, lower order terms, right? But here, for the main term, cubic term, it is half, right? So we can save cost. Okay, that is why we consider special algorithm. And for solving the lower triangular system Ly equal to B, then we use forward substitution. It's okay? Ly equal to B. So from the first equation is L11 multiply Y1 equal to B1. So we can obtain Y1 equal to B1 divided by L11, right? And the second equation should be L21 multiply Ly1 plus L22 multiply Y2 equal to B2. You already know L1, Y1, so we can move this to the right side and divide it by L22. We can obtain Ly1, Y2, right? Continually, we can obtain other Y. Okay? This is forward substitution formulas, right? It's okay? And how many multiplications we need? Now you see, here, to obtain Y1, we need once division, right? For obtain Y1, for example, we want to obtain Y2, then here we need the multiplication, right? And then we need divided by L22, so one division. So to solve Y1, we need once division. For Y2, we need twice, right? Twice, once multiplication and once division. So 2, right? And you should know Y3, it is 3 times, and to last is n. Last is n. So it is a summation of I from 1 to n, right? So you know the summation is n squared over 2 plus n over 2. It's okay for you? Okay, last step is to solve the upper triangular system. L transpose multiply x equal to 1 equal to y. It's okay? So we come to the last equation, backward substitution. Remember? Okay, we practiced before, right? So now I just show you the formulas. Firstly, you solve xn equal to yn divided by lnn, right? Because the last equation is lnn multiply yn equal to, here should be ln equal to yn, because this is x, this is y. It's okay? Okay, and then you can consider ln minus 1, xn minus 1 plus it should be ln minus 1, ln minus 1, n minus 1, lx multiply x, n minus 1 plus ln n minus 1 multiply ln equal to y n minus 1, right? It's okay? The last second equation, and you can solve xn minus 1 because we already know xn, right? So multiplication, division twice. Okay, so also we know the multiplications and division counts is all still same cost, right? To solve a lower triangular system and to solve the upper triangular system, the cost, they are same, right? It's okay for you, remember? Okay, now we can obtain totally by using the Cholesky algorithm, factor L, and solve the two triangular system. Totally cost, you should know n square, right? Okay, the totally cost here, you should know here is n cubic over 6. Okay, also here is n square term, but later n square and n square. So you don't change, that means you don't change the cubic term, right? You don't change the cubic term. So if we just compare the cubic term, because for large number n, we only need to compare the highest order term, right? So here you see 6 and 3 as denominators. So the cost is half. Are you okay? So this is Cholesky algorithm. The compare with Gaussian elimination. the general Gaussian elimination for general case, right? The cost is half for Cholesky factorization. Okay, the last thing I want to introduce you stability of Cholesky algorithm. Okay, what is mean stability? You should know stability means by computer because we always with float number. Okay, and computation we have errors in each multiplication and division, right? So now we also need to consider the stability. That means if we input matrix A, right, then output is L. It's okay for you? So the elements Aij are input numbers and Lij are output numbers. So stability means if there are some errors on input numbers, what's the error for the output numbers, right? The errors can be controlled. If the errors can be controlled, then the algorithm is stable. Otherwise, it is not stable, right? Okay, now you see, by this formula, how to compute Lij by Cholesky algorithm. Because we know Ajj is the summation of the square. It's okay for you? We just obtain this formula. K from 1 to j, Ljk square. Okay, because here is square, so we know for each element Ljk, the modulus or the absolute value should less than or equal to the square root of Ajj. It's okay for you? So that means now you see, that means, okay, we can use Ajj as bound for Ljk. Okay, so that means the round of errors of the entries of L can be controlled during the algorithm. Okay, if you here you have some errors for Aij, okay, or for Ajj, okay, because also controlled for Ljk, because Ljk absolute value less than square root of Ajj. It's okay? So that means the Cholesky algorithm is stable. Okay, so that is why this is also famous algorithm, Cholesky algorithm. Okay? Okay, finally, let's come to an example. To solve the following linear system by Cholesky algorithm. Now A is 4 minus 1, 1, minus 1, 4.25, 2.75, and 1, 2.75, 3.5. B is 4, 6, 7.25. Okay, now, firstly, we need to obtain L, the lower triangular matrix. Now, this is the result. 2 minus 0.5, 2, 0.5, 1.5, 1. And also, we can solve the linear system, lower triangular linear system, Ly equal to B. Then we will obtain y equal to 2, 3.5, and 1. T means colon vector, right? Okay. And last, you need to solve L transpose X equal to Y. Then you will obtain the result. 3 ones for X. Okay. Now, I just show you this is a figure. Now, this is a figure by the software. Okay, Mathematica. Okay, a famous mathematical software. Also, you can use MATLAB. But I just show you now the code. This is the code, the picture from my computer. I show you the code. Now you see the input A is a 3 by 3 matrix. And the right term we use B. Okay. And now Aij, you see Aij are the entries of the matrix. I from 1 to 3, J from 1 to 3, 3 by 3, and Bj, right? The 3 numbers. Okay, now n equal to 3, 3 by 3. Now you see, we just use 2 formulas to obtain all the elements of Lij. Firstly, Ljj, now you see, Ljj square root, the formula is Ljj equal to, here J, okay, equal to the square root of Ajj. Now you see Ajj minus the summation. Sum means the summation, the code. Okay, code K from 1 to J minus 1. And Ljk multiply Ljk multiply Ljk. It's okay for you? Now, this is just the first equation. Now you see, just by this formula directly, and also we use the second formula just by code, right? It's okay to program. Okay, now you see, next, okay, J from 1 to n, J加加, right? And I from J plus 1 until to n, right? I 加加 and Lij, this formula. Now you see Ajj, Aij, Lij equal to Aij minus the summation K from 1 to J minus 1 here, right? Lik multiply Ljk and divided by Ljj. You see, remember, this is the second formula. Directly by program, then I can show. Okay, also here, I just show you the L matrix 2 minus 0.5, 2, 0.5, 1.5, 1. Okay, this is just by my code. My code, now you see, because I want to show you L transpose. L multiply L transpose. What is L transpose? Now you see, Lij equal to Lji, just the transpose. Okay, so that means I put the elements of L transpose with L together. Not to make a mistake, okay? Of course, you don't need this one for you, okay? I just show. Okay, now we obtain L. Then, again, by the two formulas, you see, to obtain Yi and Xi. Now you see, Yi equal to Bi minus summation Lik, Yk, and divided by Lj, Lii. Okay? These two, just the two. Now you see, just these two formulas. Directly, you can compare, okay? With PDF file and with my video. Okay, now you see, by the two formulas, we can obtain finally 3 ones. Okay, now by 3 steps. Firstly, we obtain L, and to solve Ly equal to B, and to solve L trans Y equal to C, equal to L transpose X equal to Y. Clear? So, of course, this is for program. For you, I ask you to practice by yourself to obtain the L matrix and also to solve. You can solve by hand actually, because it's just 3 by 3. Very easy. So I hope you can check, okay, by your practice by yourself.